This is the 9-5 lesson, solving quadratic equations using the quadratic formula. Your objective today is that you will be able to solve quadratic equations using the quadratic formula. So, just to get this kind of going right off the top of the bat, there is an equation called the quadratic formula. Quadratic formula. And the quadratic formula is a very handy tool. It's not all that easy to work with, but it works. And the kind of cool thing is it just about always will work. And so what we use the quadratic formula for is to solve for x, to find our x-intercepts. And there's I'm going to write out the equation for you. So the equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the quadratic formula is one of those formulas that you should you need to commit it to memory. It's much like Pythagorean theorem, which you should know. I believe you should know at this time. A squared plus b squared equals c squared. That's Pythagorean theorem. The quadratic formula is much the same. There's actually a sing-song thing to it. If you know Pop Goes the Weasel, it goes x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. And there you have the quadratic formula song. Try singing that a few times, refresh it if you need to, kind of go back and go through that a few times until you kind of got it. You can find plenty of examples of the quadratic formula songs online, thanks to teachers kind of assigning it as something that people need to know. And you'll actually probably hear me singing it as we go through this. Just that's how I learned it. So number one, to start off with, we have 2x squared minus 5x plus 3 equals 0. And what we need to realize is the quadratic formula works out of when we have ax squared plus bx plus c. That's the only way that the quadratic formula works, is if we have it in this format. We might not have a b, we might not have a c, we might not have an a. That happens. But that does not, it is necessary that it's kind of in this format or style. And so what we do is we can actually use the equation to find our x's. So x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay. And so what I need to do is I need to figure out, okay, this is a, this is b, and this is c. You should be somewhat familiar with that from standard form. And so I'm going to plug stuff in. So x equals the opposite of b. My b value was negative 5, so minus negative 5 plus or minus the square root of b squared, which is negative 5. We already determined that b was negative 5, squared minus 4 times my a value, which in this case is 2, times my c value, which is 3. This is all divided by 2 times my a value, which is 2. And this seems like a lot of numbers. It is. And so what we're going to do is we're going to kind of work our way through it. So x equals negative 5. That makes a positive 5. We're going to leave this plus or minus here, and we'll kind of talk about what that's doing here in a little bit. Square root negative 5 squared is 25 minus 4 times 2 is 8 times 3 is, 4 times 2 is 8 times 3 is 24. All over 2 times 2 is 4. So my x equals 5 plus or minus the square root of 1 divided by 4, which is the same as 5 plus or minus 1 over 4. Now, as you might be able to kind of guess from this, we're going to do two equations. We're going to do it when x equals 5 plus 1 over 4, and when we have 5 minus 1 over 4. And so my answers for that become x equals 6 over 4 and 4 over 4. And so my x values are, let's see, that becomes 3 over 2 and 1. And so those are values that when I plug them in should give me 0. We can test this. We can even do 2 times 1 squared minus 5 times 1 plus 3. This is 1 squared is 1 times 2 is 2. Negative 5 times 1 is negative 5 plus 3. Negative 3 plus 3. And 0 equals 0. We can do the same thing with 6 over 4. Or 3 over 2. Let's go to the next one. And so we have an equation, and I need to make sure that's in standard form. X squared minus 6x plus 5. I go from my least power, or my highest power to my least power. Okay, so everything's fine. Everything's combined. So I'm going to use, I guess, first, it is possible for us to factor this. And so we could do factors of 5, which are 1 and 5. And those add, 1 and 5. And those add up to make 6. And so I know that my answer could be x minus 1, x minus 6, or 5. I really want to put 6 down. And that's good to know, because we can, from there we can say, hey, my x's should be 1 and 5. And that's handy to know. If you're in the middle of a problem or something like that and you can see that, go for it, use it. However, if you don't see that, you can always use the quadratic formula. So x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay. And I can plug values in. So x equals the opposite of, this is negative 6 plus or minus the square root of negative 6 squared minus 4 times, my a value is 1, times c, which is 5. And this is all divided by 2 times 1. So my x kind of starts, we start shaking down the x, and we go, okay, this is 6 plus or minus the square root. This is 36 minus 4 times 1 is 4, times 5 is 20, divided by 2. So I get x equals 6 plus or minus the square root of 16 divided by 2. So x equals 6 plus or minus the square root of 16, 4 over 2. And so we kind of get two equations from that. So x equals 6 plus 4 divided by 2, and 6 minus 4 divided by 2. And from that, we get that x equals 10 over 2 and 2 over 2. And so my answers are 5 and 1, which happen to be the same as we figured out before. And so that's the really great thing about the quadratic formula, is if you don't remember how to factor, or if you don't know how to do any of that, and you can get it in this format, this ax squared plus bx plus c, you can solve it that way. It's a little more work, yes, but you'll be able to do it. And that's what's really cool about the quadratic formula. All right, number 3. Negative 3x squared plus 2x plus 7 equals 0. And I go, okay, is this in standard form? X squared first, x, and then no x. All right, yeah. And so I can use the quadratic formula, because when I look at this, I go, yeah, I have no idea what this combination is that could possibly make 2. And so I go, all right, time for the quadratic formula. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay. So x equals negative my b value, which is 2, plus or minus the square root of my b value, which was 2, squared, minus 4 times a, which was negative 3, times c, which is 7. All divided by 2 times negative 3. And so I get x equals negative 2 plus or minus the square root. 2 squared is 4. Negative 4 times 3 is positive 12. Times 7 is positive 7 times 12, 84. Yeah, 84. All divided by negative 6. So I get x equals negative 2 plus or minus the square root of 88 divided by negative 6. Now, I don't, off the top of my head, I can't tell you what the square root of 88 is. And this is where the last lesson comes into play. In that we can go, oh, what's the square root of 88, or kind of how can we simplify this? Well, the square root of 88 turns into 8 and 11. And 8 is 2 and 4. And 4 is 2 and 2. And now I have everything kind of primed. And so I go to the next step and I go, okay, x equals negative 2 plus or minus 88, whenever I factor this out, is 2 square root of 22. So it's negative 2 plus or minus 2 square root of 22, all divided by negative 6. And surprisingly enough, this is our answer, assuming you don't have a calculator. If you had a calculator, you'd be able to kind of evaluate this a little further. And I guess that actually in reality we can actually simplify this, because 6 goes into both negative 2 and 2. And the negative actually would cancel out. So we'd have 1 plus or minus the square root of 22 over 3. Those should be your answers. Okay. And that's as far as you need to go with this, which is kind of cool because unless you're specifically given a calculator, this is as far as we can evaluate. And so we kind of say, yeah, it's 1 and some change. We're not sure what. All right, number 4. Number 4, I have 4x squared minus 4x equals negative 1. Now the big thing here is to recognize that we have this negative 1 on the wrong side. So we need to first set this up into standard form. So I add 1 to both sides. And I get 4x squared minus 4x plus 1 equals 0. I go, all right. Now I can use the quadratic formula. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay. Now I need to plug in values. This is my a, this is my b, this is my c. Okay. So x equals negative, my b is negative 4, plus or minus the square root of b squared, so negative 4 squared minus 4 times my a value, which is 4, times my c value, which is 1. All divided by 2 times 4. And so I get x equals negative 4 makes a positive 4, plus or minus the square root. Negative 4 squared is 16. Negative 4 times 4 is negative 16, times 1 is negative 16. All divided by 2 times 4 is 8. And so x equals 4 plus or minus the square root of 0 over 8. And the square root of 0 is 0. And so this is the same as 4 plus or minus, oops, not plus or minus, because plus or minus 0 is just the same number, 4 over 8. Now, what does that mean that we only got one answer? And this reduces down to 1/2 in case you're curious. What that means is all that's happening on a graph, that was really great. All that's happening as a graph is my x value is at 1/2, and that's where my graph comes down, touches the graph, and then comes back up, or touches the x-axis and then goes back up. And so it has an x-intercept as the same place as its vertex. That's all that means. Okay. All right. Let's do an actual graph. So if I'm given an equation, y equals negative x squared plus 4x minus 4, and we're going to try and do a bunch of stuff with this. We're going to find the axis of symmetry, the vertex, the y-intercepts, the x-intercepts, make a table of values, kind of all that stuff. So if I start with my axis of symmetry, you'll recall that to find our axis of symmetry, or our x value, we did negative b over 2a. Wait a minute, doesn't that look familiar? Doesn't that look a little bit like that? And it actually is, it does originate from this. And so you can actually work with that in kind of a later time. You could actually utilize that in order to kind of figure out some stuff, which is really cool. All right, let's get back to it though, where my negative b is negative 4 divided by 2 times negative 1. And so I get that negative 4 over negative 2, which means I get 2. So my x value, my axis of symmetry, is x equals 2. That also means that my vertex, the x value is 2. And I need to plug in 2 to the equation. So y equals negative 2 squared plus 4 times 2 minus 4. So I get y equals 2 squared is 2, or 4. So I get negative 4. 4 times 2 is 8 minus 4. So my y value is negative 4 plus 8 is positive 4, minus 4 is 0. So my vertex is 2, 0. Okay. Next thing I have is my y-intercept. And my y-intercept is when x is 0. What do I get? Well, when x is 0, I get y equals negative 0 squared plus 4 times 0 minus 4. So I get y equals negative 4. So I get negative 4. Again, this could just be your c value if you remember that. Now the next thing that I have to find is my zeros. And maybe I'm good with it, maybe I'm not. You could have tried factoring and you would have been like, oh man, you know, that just doesn't quite work. And so what we can do is we can use our quadratic formula. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay. And what we do is we plug in our a, b, and c values. So my b is positive 4 plus or minus the square root. B squared is 4 squared minus 4. My a is negative 1 because it has that negative out front times 4. Negative 4, sorry. Negative 4, because my C value is that negative 4 right here. Okay. All over 2 times negative 1. So I get x equals negative 4 plus or minus the square root. 4 squared is 16. Negative 4 times negative 1 is positive 4. Positive 4 times negative 4 is negative 16, all divided by negative 2. And so I get x equals negative 4 plus or minus the square root of 0 all over negative 2. Well, this winds up just being that x equals negative 4 over negative 2, which is the same as positive 2, which also happens to be our vertex. Okay, I'm going to make an XY table. And I'm going to choose some numbers. And the number that I always start with is my vertex. And I say, okay, that one was 2, 0. It's also of note because it's also the x-intercepts. A couple things I'm going to go for is I'm definitely going to try and get my y-intercept in there because I already figured that out. And fill in a few values. So I'm going to choose 1, 3, and 4. So if I plug in 1, I have negative 1 squared plus 4 times 1 minus 4. So I got negative 1 plus 4 minus 4. And that winds up equaling negative 1. Now, because 1 is 1 away from 2, and so is 3, 3 should hopefully have a value of negative 1. Negative 3 squared plus 4 times 3 minus 4. 3 squared, 9, negative 9. 4 times 3, positive 12, minus 4. Negative 9 and 12 make 3. 3 minus 4 is negative 1. Now I do 4. Negative 4 squared plus 4 times 4 minus 4. Lots of 4's in that problem. Hopefully the answer is negative 4. Go figure. So 4 squared is 16. Put a negative on it. You got negative 16. 4 times 4 is positive 16 minus 4. And so we get negative 4. Draw a little graph. One, 2, 0. 3, negative 1. 1, negative 1. 0, negative 4. 1, 2, 3, 4. 4, negative 4. And we graph. There we go. Make sure you label your points. So this is 2, 0. This is 3, comma, negative 1. 1, comma, negative 1. 0, comma, negative 4. 4, comma, negative 4. All right. Let's do another one. So we got y equals 6x squared plus 2x plus 1. We'll start with our axis of symmetry, where x equals the opposite of b divided by 2a. And so we got negative 2 over 2 times 6. And so my answer is negative 2 over 12, which equals negative 1 over 6. That's my axis of symmetry. And so that's also what I plug into my vertex. My vertex is 1 over 6 comma something. And so I'm going to plug that in. So y equals 6, 1 over 6 squared plus 2 times 1 over 6 plus 1. So y equals 6 times 1 over 6 squared is 1 over 36 plus 2 times 1 over 6 is 2 over 6 plus 1. So I get y equals 6 times 1 over 36 is 6 over 36 plus, I would reduce, but I know ahead right now that would actually wouldn't be necessary, so I'm going to leave this as 2 over 6 plus 1. I'm going to reduce this one though, and it gives me 1 over 6 plus 2 over 6 plus 1. And so my y equals 1, and 3/6 is the same as 1/2. So 1 1/2. That's my vertex. My y-intercept is when x is 0. So y equals 6 times 0 squared plus 2 times 0 plus 1. And so my y-intercept is y equals 1. Okay. Alrighty. So 0 comma 1. Now if I do my x-intercepts, or also called my zeros, I'm going to use the quadratic equation. So x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. So my x equals the opposite of b, which is 2, plus, oops, no it's not. Yeah, it is. Plus or minus the square root of 2 squared minus 4 times a, which is 6, times c, which is 1, all divided by 2 times 6. So I get x equals negative 2 plus or minus the square root of 4 minus negative 4 times 6 is negative 24 times 1 is still negative 24. All divided by 12. And so I get x equals negative 2 plus or minus the square root of negative 20 over 12. Now, we didn't really talk about it in the last lesson, at least not on the online version. We mentioned it, but we can't do the square root of a negative number. It's not real, and that's kind of the big thing right there, is that this idea of a real number. As far as kind of you're concerned in terms of creating a graph, what this means is it doesn't cross the x-axis. In reality, what this means is it becomes what's called an imaginary number. We call it I. And from there, you could evaluate it, but you're going to have this thing that has this I with it. And so you can actually still continue evaluating. The square root of 20, that's 4 and 5, so which is 4 is 2 and 2. So you'd have 2i square root of 5. So you get x equals negative 2 plus or minus 2I root 5 over 12. And this simplifies down to -1 plus or minus I root 5 over 6. And so there is no x-intercept. No intercept. Means it's above the graph. Graph. There we go. Okay. And I just realized that when I was calculating the vertex that I made this positive. It should have been a negative. So that would have made this -2. It wouldn't have any effect over here because it multiplies out. That makes this -2x, or -2 over 6, -2 over 6. What that changes is my y, or the y value of my vertex should actually be 5 over 6. I was thinking about it kind of a little bit. So 5 over 6. It seemed weird. All right. So I'm going to make an XY table. And for my x's, again, I am going to start with my vertex, which was 1, 6, and it gave an answer of 5, 6. And I'm going to go in both directions. 0 and -1, 1 and 2. Now, I need to keep in mind that doing this is going to change. They're going to be different because 1/6 is closer to 0 than it is to 1. We actually already figured out 0. 0 was 1. And now I can plug in -1. So I go 6 times -1 squared plus 2 times -1 plus 1. -1 squared is 1 times 6 is 6. 2 times -1 is -2 plus 1. 6 minus 2 is 4 plus 1 is 5. If I do 1, 6 times 1 squared plus 2 times 1 plus 1. 1 squared is 1 times 6 is 6 plus 2 times 1 is 2 plus 1. This equals 9. 6 times 2 squared plus 2 times 2 plus 1. 2 squared is 4 times 6 is 24. 2 times 2 is 4 plus 1. So 28, 29. Well, that escalated quickly. But now I can graph it. I'm not going to do all the way to 29, just in case you're wondering. But I can graph this. So I can go 1, 6, 5, 6. I'm going to guesstimate that it's there. 0, 1. -1, 5. 1, 2, 3, 4, 5. 1, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so I have a nice little graph. And so I got 1 over 6, comma 5 over 6. And I got 0, comma 1. And I got -1, comma 5. And I have 1, comma 9. And that's my graph. All right. One last one. If I have y equals 1 over 2 x squared minus 7x plus 1. Figure out my axis of symmetry, which is the x value is x equals -b over 2a. And so that's -7 divided by 2 times 1/2. With that, I'm going to get a positive 7. 2 times 1/2 is 1. So my axis of symmetry, my x equals 7. my vertex, the x value of my vertex is 7. And then I need to plug in a value. So I go y equals 1/2 of 7 squared minus 7 times 7 plus 1. So y equals 1/2 of 49 minus 49 plus 1. Let's see. This becomes 24.5 plus, or oops, minus 49 plus 1. So y equals negative 24.5 plus 1. So y equals negative 23.5. Okay. I'm going to do my y-intercepts. So my x is 0. What is my y value? Well, my y value winds up being 1. Okay. Find my x-intercepts. So my x-intercepts, x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. So x equals negative, my b value was negative 7, plus or minus the square root of 7 squared minus 4 times 1/2 times 1. All divided by 2 times 1/2. And so I get x equals 7 plus or minus the square root of 49 minus negative 4 times 1/2 is negative 2 times 1 is still negative 2, all divided by 1. X equals 7 plus or minus the square root of 47 divided by 1. And really, I could just start leaving off this 1. Now, I'm pretty confident that 47 is a prime number. Actually, yeah, it is a prime number. So I would actually leave it just like that. And where that's a little difficult is we're wanting to graph it, but what that tells us is, okay, we just kind of can't. And we can actually somewhat approximate this because it's pretty close to 49, so that tells me that I'm plussing or minusing something to, and 49 is 7 squared, something a little less than 7, so it's like 6.9, let's just say. So that tells me I should be kind of near 0.1 and kind of near another number. All right. So the next thing that I do is I make a table of values, x, y's. And I'm going to start at my vertex, which we said was 7, negative 23.5. And we didn't really have any nice numbers until we got to 0. And that gave us 1. So I might just do like 6 right here. And then I'll probably do 8 here to go 1 in this direction. And then 0 is 7 away from 7, so I could do 14 down here. And if I do this, I do 1/2 6 squared minus 7 times 6 plus 1. 6 squared is 36. Half of 36 is 18. Minus 7 times 6 is 42 plus 1. As you can see, this is kind of getting a little bit annoying. let's see, I'll use my calculator for this. 18 minus 42 is negative 24, minus another one is negative, or plus 1 is negative 23. 1/2 of 8 squared minus 7 times 8 plus 1. 8 squared is 64. 64 divided by 2 is 32. 7 times 8 is negative 56 plus 1. So 32 minus 56 is negative 24 plus 1 is negative 23. That matches up as it should. 14, I'm just going to save us a bunch of math. I'm just going to tell you it's 1. And so we can graph this. X's are in the positives. Alright. And again, we're kind of got some really big numbers here. And so I got 0. Whoops, wrong way. Undo. There we go. When x is 0, my y is 1. When x is 0, my y is 1. There we go. And then everything was down at like negative 23, except for whenever we were at 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so I know that it's kind of really big and wide. This goes down to negative 7, comma, positive 7, negative 23.5. Okay. Alrighty. And that is, okay, yep. So that's everything. Check with your teacher on what the problem is, and have a good one.